Pythagorean Theorem. And the Pythagorean Theorem is something that you all have been exposed to and have done things with. Okay? The Pythagorean Theorem says that if you have a right triangle, then the sum of the squares of the legs equals the square of the hypotenuse. If you have a right triangle, then the sum of the squares of the legs is equal to the hypotenuse. Write this down in a way that makes sense to you. If you want to write legs squared plus legs squared equals hypotenuse squared, then write that. Okay? Whatever makes sense. These are your notes. But our book says that in a right triangle, the sum of the squares of the legs is equal to the hypotenuse squared. So the most important thing to do is to be able to recognize what's the hypotenuse and which ones are the legs. So which one is the hypotenuse? In this particular drawing, it is the C, okay? And it's not always the C. Sometimes they'll put an X out there. So how do we recognize it when we have a right triangle? Yes, sir. It's the longest side. It's the side opposite the 90-degree angle in your first block. Okay? The two legs are the two sides that form the right angle. They make the 90-degree mark. They're perpendicular to each other. Okay. Everybody good? Ready for the next slide? You learned this part, okay? I'm not sure if they formally presented the next one for you. So, all this time, the last 3 days, we've been talking about how to simplify radicals. This next slide is going to talk about the few exceptions to the rules, the ones that are radicals that actually come out nicely, okay? They're called Pythagorean triples. A Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the Pythagorean theorem. They have to be integers. There's your key word there. An integer is a counting number, usually positive or negative, but we don't think about sides as triangles as having negative sides. So when we're talking about integers, we're talking about 1 and 2 and 3 and 4 and 5 and so forth. All of the ones that we're familiar with, but then we remember that we can have decimals and fractions, right? Those are not integers. So fractions are called rational numbers, and square roots are called irrational numbers. So these are special numbers, special sides in a triangle that do not come out to be a radical. They actually are perfect squares when it's all said and done. No. We'll get through them quickly. Okay? All right, so let's think about this. Okay? 3 and 4. If 3 and 4 are the legs of a right triangle, how would you find the third side, the hypotenuse? It's not 7. 25. Why? So 3 times 3 is 9. 4 times 4 is 16, and 9 plus 16 is 25. So 25 is c squared. What does c have to be? 5. So 3, 4, and 5 are 3 sides of a right triangle. 3 squared and 4 squared gets me 25 squared, or 25, which is 5 squared. Okay? All right? So Skylar, plug this into your calculator. Find out what 5 squared plus 12 squared is for me. Con, would you plug in 8 squared and 15 squared for me? Okay. Brian, you've got 7 squared and 24 squared. Okay. Jaden, 6 squared and 8 squared for me. Okay. What'd you get? That's right. No, put it in red. Okay. But what is the square root of 169? What is the square root of 169? 13. Okay. So we don't want to leave it in squared form. We want to take the square root of it. Okay. Con, what'd you get? At the moment. Okay. Don't think so. Try it again. 8 squared plus 15 squared. What'd you get? And then take the square root. Turn it sideways. You turn your calculator sideways. It gives you a square root button. Good. It's right up there. Okay. Good job. Brian, what'd you get? Okay. That's a 17. Okay. So 7 squared is 49, right? And 24 squared is, okay, add them up. And then when we take the square root of 625, what do we get? Good question. Okay, so perfect. So Peyton's already figured out a shortcut here. Okay. The shortcut, she said, is, wait a minute. I've noticed now that we have these base ones here, that 6 is double 3. 8 is 4 doubled. So she's predicting that this will be 10. Let's see if she's right. What is 6 squared? What is 8 squared? 36 plus 64 is, and the square root of 100 is 10. So if you can remember these base Pythagorean triples, these special cases, then you can generate more of them by doubling them, and by tripling them, okay. That's fine. I've got mine in the back, thank you. Okay, so we found our base ones, and now if we double them, we get our next row, double, 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 triple, triple. When we triple 17, 17 times 3 is 51. 25 times 3 is 75. Okay. Now we'll quadruple. What is 4 times 5? What is 13 times 4? 52. Double 26. What is 17 times 4? 64. 68, thank you. And 25 times 4? 100. So we have a base table of Pythagorean triples that a teacher could use to make you have nice, neat, even, whole integers for answers. And these are the few of them out there. There are many more that won't make nice, neat Pythagorean triples for you. Most of the time you're going to see radicals, and that's why we spent time working on radicals. Okay? All right, so next example. Find the value of x and then decide if this is a Pythagorean triple. Not yet. Oh, you said that the last time and you never came back, so no. Okay. So, work it out, guys. What is x on this triangle? Okay. And the square root of 41 is the answer I'm looking for. Okay. Okay, so first step on these is to make sure that you are looking at the right part. This is the hypotenuse, right? Okay, so we want this to be the answer in our equation. Okay? Shh, guys. So, x squared is 5 squared plus 4 squared, the two legs. X squared is 25 plus 16, and that adds up to 41. Now, if x is squared, what's the opposite of squaring something? The square root. We take the square root of the left, we take the square root of the right. And x will be the square root of 41. In geometry, we get to be lazy, and we get to say just plain old square root of 41. In algebra 2, we can't lose the negative square root of 41. Okay, it's plus or minus the square root of 41. But it doesn't make sense to have a side that has a negative length, right? So we get to drop that negative and just think about the square root of 41. Now, yesterday and the day before and Friday, we talked about how to simplify those. Does 41 have a perfect square in it? No, so we're finished. Okay? We want the exact value if possible. Now, is this a Pythagorean triple? No, because it doesn't come out to an integer. Okay, a nice counting number. All right, so next example says, tell whether this side forms a Pythagorean triple. First find it, and then tell me whether it forms a Pythagorean triple. So first question you ask yourself is x a leg or a hypotenuse? A leg, so put it in the appropriate spot in your equation. So Cameron, what will my equation say? X squared. Is it equals or plus 15 squared? It's plus because we have legs, okay? So plus 15 squared is equal to 25 squared. Okay? And Mackenzie, what is 15 squared? Very nice. And what's 25 squared? Very nice. Okay? And John, what are we going to do to simplify this and get the x squared by itself? Take 625 minus the 225. And so x squared will be what, Nolan? What is 625 minus 225? And then we want to get the x by itself, and it's currently being squared. So we square root it. Does anybody recognize a perfect square in 400? 20. If you recognize that, pop it in there, you're done. If you don't recognize it, you can start working on your product of primes or making your cake, and away you go. Is this a Pythagorean triple? Yes, because we have integer, integer, integer. Absolutely. Instead of making the cake, you can guess in your calculator. You can say this is even, or I think it might be divisible by 4, and see 4 times 100. 4 is a perfect square, comes out as a 2. 100 is a perfect square, it comes out as a 10. 2 times 10 is 20. So there's lots of ways to simplify. You bet. Okay. All right, next example. When someone installs a high thing like a tower, they like to anchor it with supports. Sometimes when they install something like a flagpole, they want to anchor that with supports as well until the concrete cures and they're sure that it's stable. So when we put up a flag and we have some support wires, we want to figure out how long those support wires are. They attach the support wires to the flagpole 15.1 feet in the air. Not usually too long. It doesn't take a terribly long time to do that. Just like apple trees and so forth. If you're planting a tree, a lot of times you like to support it. And the bigger the tree, the longer your wires are going to be because you support it higher. Usually concrete will cure in a couple weeks to a month, depending on when it's installed. Okay, so we have 15.1 feet. Is that a leg or a hypotenuse? The 15.1 feet. That's a leg. Okay, we've got 8.5 feet away from the base that they've installed it. Is that a leg or a hypotenuse? So we're looking for the hypotenuse. So Peyton, what's the equation going to say? Sorry, that's okay. That's okay. And what's the only thing that you're missing? X squared. Good. Okay, so x squared is 8.5 squared plus 15.1 squared. Peyton H, what is 8.5 squared? Okay. Okay. 72.25 is our, when we square them and add them up, so we have to take the square root of it. Okay, good. So 72.25 plus, okay, and so that's 300.01, right, is equal to our x squared, so we square root 0.06, thank you, and 17.31 is about equal to our x. So this is the time when it's okay to plug it into the calculator and get the decimal, because they said approximate the length of the wire. Yes, thank you. 300.26. Okay, yes. Not right now. Okay, let me finish this. Okay. All right, away we go. That's not what you got? Okay, so let's check. When we plug in, and you have to be careful with your order of operations, and I'm glad that you mentioned it, because sometimes you can get the wrong answer by if your calculator doesn't understand them properly. So 8.5 squared is 72.25. 15.1 squared is 228.01. So when we add that to the 72.25, we do get 300.26 and then the square root. So something in your calculator wasn't quite right. It should be 17.33 if we go to the hundreds place. Okay. All right, I'll come help you. There's something in your calculator that's not going in the right direction. Okay. All right. So the Pythagorean theorem said if you have a right triangle, then the leg squared plus the leg squared is the hypotenuse squared. Okay, what will the converse of that say? Remember what the converse said? Switch them, right? So I started with, if you have a right triangle, then leg squared plus leg squared is hypotenuse squared, right? If two sides squared added up together is the third side squared, then it will be a right triangle. So write that down in any way that makes sense to you. Don't use these words, okay? Unless these make sense. If the square, whatever makes sense to you, okay? If the square of the longest side equals the sum of the squares of the other two sides, then the triangle's right triangle. if the square of the longest side equals the sum of the squares of the other two, then we have a right triangle. Absolutely. If c squared equals a squared plus b squared, then right triangle. Okay? As long as you remember to find your longest side and make that your c. Okay? Yes, sir. Because if you are a construction worker and you can measure two sides and see if one of them squared plus the other one's, oh, the wording, absolutely not. It's necessary, but it's very precise wording. It's mathematical wording. Okay? That's why I say make it your own words. Make it make sense to you. It helps your vocabulary. It helps you have to think logically and reasoning. Okay? So everybody has this one down? Okay, let's hustle. Okay? So if the third side squared, or the biggest side squared, equals the other two squared and added up, we know we have a right triangle. All right. So on our next slide, on your next examples, I have two triangles, and I want to know if these are right triangles or not. Notice the lack of the right angle marks. Instead, they've given you sides, and they want you to decide whether this is a right triangle or not. So which of these sides is the longest side? 12, okay? So we think that the 12 is the longest side. That means that we want to say 12 squared, and is that equal to what? 8 squared plus 4 square roots of 5 squared. Okay? So Stephen, what's 12 squared? 144. Con, what is 8 squared? 64. And how are we going to square 4 square roots of 5? What do you think, Josh? Going to get rid of the square root, exactly. So this, when you square a square root, it's gone. And what do we have to do to the 4 then? Times it by 4. So we want to square the 4 and then take the radical away from the 5. Because squaring 4 square roots of 5 means take it times itself. So we'll have 16 times 5, which is, that's supposed to be a 1. So that's going to be 80. So 80 plus 64, does that equal 144? Yes. So we know that we have a right triangle. We can't just look at it.
Wait, what about those protractor things?
Even with the protractor, because we're not sure we're adequate. Okay. So now we're going to check the second one. You guys know me, right? If one of them works, then the other one's not going to. We do need to do the math. Okay, so 2 square roots of 30. What do you think? Is that the longest side? Let's think about it. Square root of 30 is not quite 36, more than 25, right? So the square root of 25 is 5. The square root of 36 is 6. This is somewhere between 5 and 6. So 10 to 12 is somewhere between 10 and 12. Is that the longest side? No. Okay. So 14 is our largest side. We want to see, is 14 squared equal to 9 squared plus 2 square roots of 30 squared? Okay. So Nate, what's 14 squared? 14 squared. Very good. Michael, what's 9 squared? And when we square 2 square roots of 30, what are we going to get? 4 times 30. We square the first, and we remove the radical from the second. 120. So does 196 equal? Nope, it's not equal to 201, is it? Okay, so we can say no, it's not a right triangle, even though it may look like it. We still need to verify. Okay? All right, last slide. The last slide is about the Pythagorean Inequality Theorem. Pythagorean Inequality Theorem says, guess what? If c squared, your longest side squared, is less than the sum of the other two sides squared, then the triangle's acute. And if c squared is bigger than the sum of the other two sides squared, then your triangle is obtuse. If they're equal, it's a right triangle. But if the c squared, the longest side squared, is smaller than the other two, it's acute. If it's bigger than the other two, it's obtuse. So that last one was acute. Okay? Okay? So, everyone has this written down? Everybody has this written down? Gentlemen, I'll take care of this in a minute. So, everyone has this written down? So, previous slide, look at your previous example. Here's our longest side, right? When we squared it, is it bigger than or smaller than the sum of the other two? Smaller. So what kind of triangle was this? Acute. Okay? So I won't have you work another one out, but we know this one is acute. So when we give you 3 sides, we can ask you, is it acute, obtuse, or right? And you can work it out to find out. When I give you 3 sides, I can ask you, is it acute, right, or obtuse? And away you go. Okay? This one's right, that one's acute. Okay? Assignment. Is a book assignment. Okay? And I had a lot of people who finished it because they got busy right away and used their time. I'm sorry. I do.